Hi viewers, welcome to my online lesson. In this video, I'm going to show you how to solve problems related to eigenvalues and eigenvectors. So, eigenvalues and eigenvectors. So that's what we are going to be talking about. But today, I might not be able to cover eigenvectors, but I'll just give you the introductory part of it. Then I will solve more of eigenvalues because of the nature of the workiness of the solution that we're going to have. So please, I want you to pay attention so that you get the trick on how to solve it. Alright, so let's start with the eigenvalues. The eigenvalues is what you are going to determine first, and after getting that, you can now get your eigenvectors. So we have an equation like this. We have an equation like this. We have an equation like this. Sorry. So the A, don't forget, is that the value of the determinant given to you, that's the value of the matrix given to you. Sorry. Then the X is the what? Is the eigenvectors. Y this lambda is the eigenvalues. You understand? So that's the meaning of this. So this is what we are going to be looking at. Then, how do we now solve this problem to arrive or to get the values which are to represent the eigens? So what we are going to do is we are going to use two approaches. The first approach is to notice that you are going to get something like this. That's the first thing you do. And after getting that, the second thing you do is to find the determinant of this answer you are putting here. So after getting the answer, it will result into cubic equation. You understand? After resulting into cubic equation, then what you do now is that you're going to find the factor. After finding the factor, then you solve it and get the values of the eigen, that is the eigenvalues. And that's why you're going to have three answers. You understand? So that the three answers you'll be getting for your lambda are the eigenvalues. After getting the eigenvalues, for you to now get the eigenvectors, what you do is you now start testing with each value of the eigens, that is the eigenvalues. You will now be testing. When your lambda is, let's say your lambda is 1, you test. When your lambda is 2, you test. When your lambda is 3, until you get the final answer. You get it? So now let's begin. So the first thing we are going to do here is to start with this. Now, don't forget that this is our A. And this is unit matrix. And unit matrix is always in line with the type of matrix given to you. If you are given 2 by 2, you use 1, 0, 0, 1. This is the high for 2 by 2. If it is for 3 by 3, like the one we have here, the high, that is the unit matrix with what? 1, 0, 0, 0, 1, 0, and 0, 0, 1. That's what you are going to have. So now what we are going to do here is, since we have A already given to us, and the unit matrix for this 3 by 3 is going to be something like this, and here we have the lambda multiplied by the unit matrix. So that will be lambda multiplied by the unit matrix will be equals to 1, 0, 0, 1, 0, 0. Then here we have 0, 1, 0, and let's say we have 0, 0, 1. So when you multiply it, that will give you lambda multiplied by this. Sorry. That will give us lambda multiplied by 1, 0, 0, 0, 1, 0, 0, 0, 1. And that will equally give us lambda times 1 will give us lambda. Lambda times 0 will give us 0. Lambda times 0 will give us 0. Isn't it? Then lambda times 0 here will give us 0, times 1 will give us, times 0 will give us 0, then times 0 will give us 0, times 0 will give us 0, and times 1 will give us lambda. So that is our lambda I, isn't it? Lambda I. So now what we are going to do is we are going to use this formula. That is, we are going to subtract this answer from this one right here. So that will give us a minus a is equals to, so our a is already here. That is 3, 2 minus 1, 1 minus 2, 3, 2, 0 and 4 minus the lambda unit matrix that we have. That will be lambda 0, 0, 0, lambda 0, 0, 0. So when we subtract this, what are we going to have? That will be 3 minus this, will be 3 minus lambda. 2 minus 0 will be 2. Minus 1 minus 0 will be minus 1. Isn't it? Then 1 minus 0 will give us 1. Minus 2 minus lambda will give us minus 2 minus lambda. Then 3 minus 0 will give us 3. 2 minus 0 will give us 2. 0 minus 0 will give us 0. While 4 minus lambda will give us 4 minus lambda. So now this is the value of this. So it is this value now we are going to find its determinants. So how do we find the determinant of this? The determinant will be determinant of A minus lambda unit matrix equals to. Now don't forget that in finding the determinants, we are going to take note of the sign. And don't forget that here will be plus, minus, plus. So if you are taking this side, that means you have 3 minus lambda into, that means you are going to plug this place and this place. So we have minus 2 minus lambda, minus 2 minus lambda, 3, we have 3. Then we have 0 and 4 minus lambda, 0 and 4 minus lambda. That's what we are going to have there. This one is minus. We have minus 2 into, this one will be like this and like this. So we have 1, 2, 1, 2. Then 3, 4 minus lambda, 3, 4 minus lambda. Isn't it? Then the number 3 is, that's minus plus minus 1. So plus minus 1 into, don't forget that in that we have, sorry, what do we have there? We have, can we repeat it so that we can get it? Let's repeat it. We have 3 minus lambda. We have 2. We have, okay, yes. We have 3 minus lambda. We have 2. We have minus 1. Then we have 1. 2 minus lambda. Then we have 3. We have 2, we have 0, and we have 4 minus lambda. So what we have not done is this one. We are not taking for 1. You understand? I said it's going to be like this. So that will be 1, 2 minus lambda, 1, 2 minus lambda, and 0. Yes. So that's it. So now after doing that, the next thing we are going to do is, the next thing we are going to do now is to solve it out. And that will give us 3 minus lambda into this and this minus this and this. this times this minus this times this. This times this minus this times this. Understand? So this will give us, let's use square bracket, minus 2 minus lambda times 4 minus lambda minus 0 times 3. So what would it give us? To give us 3 minus lambda into minus 2 times 4 will give us minus 8. Minus 2 times lambda will give us plus 2 lambda. Minus lambda times 4 will give us minus 4 lambda. While minus lambda times minus lambda will give us plus lambda squared. Then this one will give you 0, so no need of repeating it. That's for the first one. The second one now is minus 2 into this times this minus this times this. So my 4 minus lambda times 1 will give us 4 minus lambda minus 2 times 3, 6. And this one will give us minus 1 into 0 times 1 will give us 0 minus 2 times this minus 2 minus lambda. You understand? So we are going to put these things together. And how do we put it together? We are going to have from here, we are going to have 3 minus lambda. This one will give us minus 8. 2 lambda minus 4 lambda will give us minus 2 lambda. Then plus lambda squared. Let's open the bracket. This will give us 3 times minus 8 will give us minus 24. Minus 6 lambda plus 3 lambda squared plus 8 lambda minus plus 2 lambda squared and minus lambda cubed. What would this one give us? This one give us minus 2. This one is the same thing as minus 2 into minus lambda minus 2, isn't it? Or what we say 4 minus 6 will give us minus 2, then this minus lambda. Then this one will give us what? Minus 1 into minus 2 times minus 2 will give us 4. Minus 2 times minus lambda will give us plus 2 lambda. So let's put everything together. We're going to have minus 2 into minus lambda minus 2 minus 1 into 4 plus 2 lambda. Now let's simplify it. Let's simplify it. Now simplifying it will give us, this one now is minus 24, isn't it? Minus 6 lambda plus 8 lambda will give us what? That's 2 lambda. 2 lambda. 3 lambda squared plus 2 lambda squared will give us 5 lambda squared. Isn't it? Then minus this one, minus lambda cubed. Minus 2 times minus lambda will give us plus 2 lambda. Minus 2 times minus 2 will give us plus 4. Minus 1 times 4 will give us minus 4. Minus 1 times plus 2 lambda will give us minus 2 lambda. Isn't it? This cancels this cancels this. So we now have minus 24, then plus 2 lambda plus 5 lambda squared minus lambda cubed. So that's our determinant is equal to this. So we can bring everything in to have lambda cubed minus 5 lambda squared minus 2 lambda plus 24 is equals to 0. So that is where we are going to continue. Now this one now is in form of cubic equation, where because we have a power of 3. So what are we going to do here now in order to get the exact value of the lambda? So in this kind of question, there's no how we are going to solve it other than to use what? To use factor theorem. We can use factor theorem where you start testing. You understand? When you start testing, you may test with plus or minus 1, test with plus or minus 2, test with plus or minus 3. What do I mean by that? You start assuming when lambda is equals to 1, when lambda is equals to minus 1, when lambda is equals to 2, when lambda is equals to minus 2, when lambda is equals to 3, when lambda is equals to minus 3, until you get your answer. You understand? So anyone that gives you a 0 as your answer is your factor. You understand? So now what we are going to do here now is that we are going to start testing. We're going to start testing. So now let's say we have 1. If we use 1, let's say when lambda is equal to 1. This one will give us 1. This one will give us what? This one will give us 1. This one will give us minus 5. This one will give us minus 2 plus 24. You see, it will never give us 0. What will it give us? That will be 24 minus 7. That's a 25 minus 5. That will give us 18. So it's a remainder. So that means lambda equals to 1 will not work. Now let me give you the clue. Lambda equals to minus 1 will not also work. It will be similar to this to 18. But let's check when lambda is equals to 2. Lambda equals to 2. So anywhere we see lambda will put 2, isn't it? So that will give us 2 to the power of 3 minus 5 into 2 to the power of 2 minus 2 into 2 plus 24. Let's see if it will give us 0. This one will give us 8. This one will give us 4, right? 10 times 5 will give us 20. Minus 2 times 2 will give us minus 4 plus 24. If you add this together, we're going to have 20 plus 8 will give us 32. 32 minus this, the answer will not be 0. It will not be 0. The answer will give us 20. The answer will give us 8, which is not a factor. So let's check if it will be minus 2 when lambda is equals to minus 2. So that means we are going to have minus 2 to the power of 3 minus 5 into minus 2 to the power of 3 minus 2 into minus 2 plus 24. So from here, this one will give us minus 8, isn't it? This one will give us minus 8 as well. And minus 8 times 5 will give us what? Sorry, this one is 2. From the question is 2, right? So this one will give us what? That one will give us 4. Right? It will give us 4. Then 4 times 5 will give us 20. Isn't it? Then this one minus and minus will give us 24. So let's see. This one will give us minus 28 plus 28. That will give us 0. So that means this is our factor. So that means lambda is equal to minus 2, which is the same thing as lambda minus 2. Is what we are going to use as our factor.